Hi guys, welcome to my channel. I'm currently studying in Sri Venkateshwara College of Engineering, and today is my subject about district mathematics structure, and topic is the principle of inclusion and exclusion. Introduction. The principle of inclusion and exclusion is counting technique used in combinations. It helps in determine the number of elements in the union and multiple sets. The principle is based on the idea of comparison and over counting or under counting the elements. The principle of inclusion and exclusion was first formatted in the French mathematicians Joseph. It is a commonly used in problem involving counting the numbers elements in the union of sets. The principle provides a systematic way to account of overlapping elements in a set. Formula. The formula of the principal inclusion and exclusion is has been given in the diagram. We can see here are the represents the number of element in a set A and so on for the set B and C. The formula adjacent for the overcounting and undercounting, the subtracting and adding the instruction of the set. Two set example. For two set A and B, the formula simplifies as been given. This formula accounts for the elements that are in the both sets A and B, ensuring they are the double counted. The principle of inclusion and exclusion is essential in counting problems involving two or more sets. Three set example. When dealing with three sets A, B, C, and the formula expands to include the instructions of all possible pairs and the triple interactions. The formula for the three sets in the crucial and scenarios of the where elements can belong to the multiple sets simultaneously. By applying the principle, we ensure an accurate count of the element in the union of the three sets. Application in probability. The principle of the inclusion and exclusion is applied in the probability theorem. It helps in calculating the probability of the union of the event of considering the instructions of those events. Probability problem involving multiple events can be solved efficiently using this principle. Overlapping events. In probability, overlapping events are the events that share common outcomes. The principle of inclusion and exclusion is used to calculate the probability of the union of these overlapping events. By accounting the interactions of the events, we avoid double counting of shared outcomes. Venn diagram representation. Venn diagram is often used in visual represent sets of their instructions. The principle of inclusion and exclusion can be illustrated using Venn diagram to show how the formula accounts for overlapping elements. Venn diagram provide a clear visualization of the relationship between sets and their instructions, and we can see in the diagram about it. Counting problems. The principle of inclusion and exclusion is commonly used in solving counting problems. It is a particularly useful when dealing with the scenarios involving multiple sets with the overlapping elements. By systematically applying the principle, we can accurate account of the elements in the union of the set. Advanced application. The principle can be extended to more than the three sets in the including additional interaction terms. Advanced application involves solving complex counting probability problems using principle and inclusion and exclusion. Mathematics and statistics rely on this principle to tackle the challenging problems involving a multiple sets. Historical signification. The principle of inclusion and exclusion has the rich history of mathematics dating back of the 18th century. Joseph's formulation of the principle laid the foundation of modern combinations and the probability theorem. The principle has since been referred to the applied various mathematical real-world applications. The principle of inclusion and exclusion has the particular application in fields such as epidemiology, computer science, and logistics. It is used to analyze overlapping categories, population, or event in real-world scenarios. By applying the principle, research and professionals can make a forward decision based on the accurate count of the probabilities. Importance in the combinatorics. Combinations in the branch of mathematics that deals with counting, arranging, organizing objects. The principle of inclusion and exclusion plays a crucial role in the combinatorics by providing a systematic approach as the counting element in sets. Combination problems are the involving multiple sets benefits from the application of this principle. Limitations. While the principle of inclusion and exclusion is powerful counting technique, it can become the complex with large number of sets. Calculating interaction of accounting for overlapping elements in multiple sets can be challenging in certain scenarios. In such cases, alternative counting method of computing and tools of made in needed. Education use. The principal inclusion exclusion often taught in mathematics course of high school and college levels. Students learn to apply the principle of solving counting and probability problem involving multiple sets. Understanding this fundamental counting technique is essential for building storing problem solving skill in mathematics. Computation in tools. Tools and software can assist applying the principle of inclusion and exclusion in the complex problems. Problems like mathematics, Python, and R offer functions and libraries for the calculating interactions and the union sets. These tools have streamlined process implementing the principle of particular scenarios. Research and development. Research and Researchers in various fields of continue to explore the expand upon the applications and the principle of the inclusion and exclusion. New methodology and the techniques are being developed to address the challenges in counting and probability problem. Advancement in the mathematicians' research contribute to a refinement and the enhancement of these fundamental principles. Problem solving strategies. When approaching a counting problems, it is essential to identify the sets of involved in their interactions, applying the principal inclusions and systematical help avoid the errors in counting elements, breaking down the complex problems into manageable steps in a key efficient utilization in this counting technique. Conclusion. And the conclusion of this topic is the principle of inclusion and exclusion is valuable tool in the combination probability theorem. By accounting for the overlapping element sets, the principle ensures the accurate count of the element in the union. Understanding and applying this principle enhance problem solving skills, facilities, and analysis in the complex scenario. Thank you so much for watching this video. I hope that you have understood what is the topic mean, and please like, share and subscribe.